Hello YouTube, it's Phil20 again. I'm going to show you what I got going on. Sorry if I'm moving the camera around. This is the diagram for everything that I'm doing right now. The only thing that's different between this diagram and what I'm doing is these two breakers. These two breakers show 60 amps here, but the breakers I'm using is 100 amps because these breakers will trip immediately whenever I'm using this diagram. So I have to switch it from 60 amp breakers to 100 amp breakers. Let's go ahead and take a look at what we got. Okay, you can see the ground fault protection breaker I've got right here. DC ground fault protection. It's tied in to this ground lug right here. This ground wire here is going down, and it's going to go through this knockout hole here, and it's going to ground our charge controller here. This is currently our bus bar. It has nothing tied into it yet, but it will directly connect to this connection right here. This is our 500 amp shunt. This is gonna this is a battery maintainer. So I'll be able to find out exactly how much power is remaining in the batteries. This breaker here is going to be the photovoltaic input. This is going to be your power coming in, and it goes to the top of our ground fault breaker here. And out of the bottom of the ground fault breaker here, we got this black and red striped wire, and it goes all the way down, and it's going to go to our charge controller when we get our hole knocked out, and our wire run through this hole here. Now we got another breaker here that is going to be the power wire coming from the charge controller. This is going to be charging our battery bank. It's going to come up to here and connect to this lug directly right here, and that's where the battery is going to connect to as well. And also from this lug we're going to send power connection through this power bar here. That way whenever we got power, we'll be able to run additional 24 volt circuit stuff off of this, or if we put additional charge controllers in, we can power them through this bar here. Like for instance, one of those charge controllers over there, I can tie into this circuit right here. So I'm just giving you a quick overview of what's going on. Oh, I forgot to show you about this big breaker. This is the large breaker. Okay, this is going to be the power going to the inverter. And here's the inverter on-off switch. Currently it's in off position. On is up, off is down. So these are the same. These are both two 100 amp breakers, and that's the breakers I was telling you about in this diagram here. I'll go give you a quick focus there. Here's the 250 amp breaker. Here's the inverter, and then our shunt, it goes to the inverter. And then we have to have everything grounded, which this is our ground circuit right here. Okay, and also this is going to be connected to the battery, if I'm not mistaken. I'm going to double check everything in the charge controller system wiring diagram and make sure everything will work with this. But I'm getting closer. I also wanted to show you about this circuit right here. I'm going to go ahead and disconnect it. This is our power wire for our inverter, coming from the breaker box that provides electricity to the transfer switch. So whenever I want to switch over the battery charger inside the inverter, all I got to do is flip a switch on the inverter, and then it immediately starts charging the batteries, and it also gives power to the rest of the house with immediate transfer switch. So I won't have to worry about turning computers off or any of that stuff neither. And if you notice right here, I don't have anything tied in yet. This is going to be our circuit going out. There's a special type of connector that I need to get, and it's very rare to find. Most of the time you'll find it in a type of RV. But when I went to the local RV store, they was going to charge me $300 for one of these connectors when I can get it on Amazon for about $100. And that's two different connectors. This connector here, I made it and built it myself. It's a 50 amp connector, 50 amp receptacle, and 60 amp wire. This is number 6 gauge inside here. This wire is really thick. It's really overrated for this type of application. It's probably going to handle 14,000 watts on this wire here. And the same thing's going to be with this wire. This wire will handle about 14,000 watts continuous. But I'll never exceed that. I will probably stay somewhere below 3,000 or 4,000 watts, hopefully. As long as everything I'm going to be running runs less than that. Hopefully it does. If not, I'm going to have to change TVs or something. Because I think my TV is the most used appliance. And it's probably the least efficient LCD known to date. Because I've had it for 9 years. 9 years or so, and it's pretty old, and it does a job. It hasn't quit yet. Sony Bravia, they'll last forever. But I've got more conduit to run. If you can see that conduit above us, we're going to take that conduit down, and we're going to move it across the top of this wall, and then down beside this conduit, and then underneath this conduit. And then we're going to go up the wall into our connector box. And then from the battery box, we're going to run some more conduit to the wall, up the wall to the conduit that's fixing to be there, and then over, and then up into the bottom of this side of this connector box. Also, I'm going to have a junction box over in here somewhere, because there's no location that is designed for this that's sealed. I can't run conduit to this machine, because if you see, the connector wires are right here on the open. I have a cover for this piece here, so I went ahead and electric taped everything here. The input requires a ground wire. Also requires 2 hot legs, 240 volts going in. 208 volts will work. 240 volts is optimal for anything. You get more voltage, more power output. And then you got your hot, and neutral leg. Now, I was reading in the manual that you cannot connect the neutral leg and the ground leg together. Damage will occur. So that's a problem. We don't need that. And also, we got another ground here. And since all this this circuit right here requires a separate leg between the neutral and the ground, they cannot be tied together. Even if you can tie them together in your breaker panel, here cannot be done. So I have to have a ground rod installed and tested, and I'll do it on the other side of this wall beside the heat pump. And I just don't want to have trouble with this inverter because I did not have the proper ground installed. So remember, if you're doing a solar system, you definitely want to have a correct ground installed. And whenever you have a ground correctly installed, you don't want to use the ground off of your breaker panel, because it's ground and the breaker panel is connected together unless it's a sub panel. The sub panel cannot be connected together at the same location as a ground wire because it's not part of code. So you ought to remember this: ground separate from neutral on any solar application. It will kill your inverter if you don't. So soon I'll get that connector. I'm afraid it'll be like 2 weeks, but I can temporary something up to run the house after I get these panels and everything installed. So I just got to run that conduit over, down, up, and back into this box here, and I got to run conduit from this box here and then back into this side here. I'll use a hole saw. This is an aluminum box, so it'll be easy to cut through this. Once I get that hole saw and cut me a 2-inch hole out, and I'll run wire to it, we'll be pretty good to go. And then we'll start doing the wiring from over here, running across and then back down and around. And then we're going to put the panels on the roof. And if you guys didn't know, bam, I've got some solar panels. I've got 12 in total. Right here is 9. I've got 3 more over there in the corner. Let's see if I can focus for you. I got 3 over there near my breaker panel. And you can see it's just your standard basic solar panels. They're 240 watts, 250 watts at 30.1 volts. That's going to be pretty sweet. But I'm just going on and trying to get everything going, and I apologize I'm not putting any videos up, but there's more coming. And I'm sorry I've got all this work I've got going on, and so I just want you guys to see what I got accomplished so far. And you guys are going to be interested in seeing some more stuff. I'm going to be putting a racking system on the roof, and the original aluminum solar racking system is around $1,000. I'm going to try to complete this job with a racking system under 150 bucks. It's called Unistrut, and if you haven't heard of it, you can take a look into it. I'm going to try to use that. If it doesn't work out, it'll work out, trust me. I'm going to get it done. I've used Unistrut many times on heat pumps, and I know how to build a rack for a heat pump and ductwork. So, you know, it's a different application sometimes, but the principle's the same. I've had to run wiring conduit over on a roof and use Unistrut to keep it off the roof, to keep the wire cooler. And this is just going to conclude my video. This is Phil at 20 with Guns, Games, and Racing, and I will holler at y'all later.